Hello everyone, how are you all? I hope all of you are safe and sound. Along with that, I hope all of you are watching the videos and understanding them and studying well. I hope this is happening and it should happen. Okay, so let us not waste our time much. Let us continue with our session. Last session I was clear with the critical angle. Okay, and I had explained the relation between refractive index and critical angle. Okay, so the same diagram. Now I have taken the same diagram on the board where it explains you both at a time, that is critical angle and even total internal reflection. Okay, let us observe. Let us imagine that this is the denser medium and this is the rarer medium. So this is a pair of mediums as usual, and the ray of light is traveling from denser medium to rarer medium. This is our situation. So we took 1, 2, 3, 4. Four different conditions in which we observe completely the whole scenario of critical angle and total internal reflection. In the first case, the ray of light from denser medium, it travels directly into rarer medium and it is in straight path, so no refraction occurs. We have studied about this. I hope you understand the condition. In the second case, the ray of light is little bit slanting, okay, oblique it is, and it travels from denser medium to rarer medium. But what happens, because it is traveling obliquely from denser to rarer medium, there is a little bit refraction. But at the point P, you can see it very clearly, at the point P what happens, the ray of light split into two different situations. A little amount of ray of light refracts in the rarer medium and a little amount of light turns back into the denser medium. Okay, that is nothing but PB. Okay, PB is the ray of light which had entered into denser medium. Now let us imagine, let us go for the next situation, that another ray of light which is moving more oblique than this, okay, and trying to come out from the denser to rarer medium. Okay, in this case what had happened, because here as the angle of incidence has increased from here to here, because this ray of incident is more oblique than previous one, the refracted ray moves away from the normal such a way that the refracted waves will start traveling along the boundary of between two mediums. Means it makes exactly 90 degrees with the normal. Please understand this condition. This condition is critical for angle of incidence. Because after this, if we increase more the angle of incidence, there will be no refracted ray and the total light which is travelling from denser medium completely turns back into denser medium. That situation we call it as total internal reflection, right? Fine. So here the ray of light. Here this condition we understood, it is a critical angle condition, that means angle of incidence is in critical situation. So I suddenly become C, or we note it as IC also. That means here above the medium, in rarer medium, refracted ray is making 90 with the normal. Simultaneously below, angle of incidence become critical. Okay, this is the critical angle situation. If I furthermore increase the angle of incidence, already it is a critical situation. If I go beyond that critical situation and increase the angle of incidence, now you can see this, the ray of light is moving very oblique when compared to the previous two rays. Then angle of incidence is greater than the critical angle. So now the ray of light doesn't go to rarer. From the point R, it turns back into the same medium. So the angle of incidence, in this situation, angle of incidence will be exactly equal to angle of refraction. When angle I is equal to R in denser medium, that means it is the condition of total internal reflection. Listen children, one more thing. In this situation, the energy, the intensity of light, whatever it is, will be exactly the same. There will be no loss of energy in total internal reflection. So in this one particular diagram, we have seen all four situations of ray of light. We have seen here critical angle, we have seen here total internal reflection. So now it's your duty to know that what are the factors which affects the critical angle. Okay, there are only two factors which affects the critical angle. Only two, and both of them are directly proportional. That is, first one is wavelength. Okay, color, what we say. Wavelength is directly proportional to critical angle. As the wavelength goes on increasing in the pair of medium, critical angle of that medium also goes on increasing. That means if I take violet light, its wavelength is least, right? So even critical angle for the pair of medium will be least for color violet. The similar way red, if I take, wavelength is greatest, right? 8000 angstroms it is. So for the pair of medium, critical angle will goes on increase with the color red. So if it is red, the critical angle will be more. Okay. Now let us come to the second factor, simple and sweet, that is temperature and critical angle. Temperature and critical angle are again directly proportional. As the temperature increases, critical angle also goes on increasing. So the temperature of a medium, let it be air, glass, whatever the denser transparent medium, whatever may be the denser transparent medium. Okay, if the temperature of that denser transparent medium goes on increasing, critical angle also goes on increasing. If it is less, then critical angle also will be less. Okay. Now let me connect you to our textbook, because see I am teaching you from the page number 94. Okay, I had spoke about this and even I had drew this diagram and I had explained, but one most important I would like to connect you or relate you, or you mark in your textbook and keep, that is this one, essential conditions for the total internal reflection. This may come for 2 marks, and this note is also equally important. This is asked as conceptual question. Now first let us come to this essential conditions for the total internal reflection. For total internal reflection, what are the essential conditions? Total internal reflection doesn't occur anywhere anyhow. It's not like that. It has two typical conditions. If those conditions are satisfied, then only total internal reflection occurs. Like when first condition is the ray of light should compulsorily pass from denser medium to rarer medium. This is very, very important. Always the ray of light should pass or travel from denser medium to rarer medium. This is first condition. And second condition, always for the pair of medium, okay, the angle of incidence. The angle of incidence should be greater than critical angle of that particular pair of medium. In the last section I spoke about critical angle of glass is 42 degrees, isn't it? 42 degrees is the critical angle of glass with air medium. I had spoke. It is not of the glass. Glass with air. If we take the pair of medium, a glass and the air, then the critical angle of glass with air is 42 degrees. Means whenever we take the medium, air and glass, then whenever the ray of light enters into the glass and trying to come out, it can come out up to 42 degree angle. After that, it cannot come out from the glass into air and it will suffer total internal reflection. That is the meaning that whenever we say critical angle of glass is 42 degrees. Okay. So what are the two conditions for critical angle? Simple and sweet. That is, first thing is the ray of light should always travel from denser to rarer medium. Second thing, the critical angle of incidence should be greater than critical angle of that particular pair of medium. If these two conditions are satisfied, then total internal reflection is occurred. Then the question comes, Miss, why should we understand all these things? What is the application of all this? Definitely there is a very, very important and effective application of total internal reflection. That is, in periscope we use mirrors, isn't it? In solar cookers we use mirrors. What for we use the plain mirrors? We need that total internal reflection. Why do we need that reflection? Because the intensity of light, we get it. Okay, whenever the ray of light falls on a surface, if it reflects back, the intensity of light we get, and we can use that light. We cannot drag the light from the sun, isn't it? We can't get it like that. We need some device where we can get that intensity of light. Here it works, as I said you while explaining, that in total internal reflection, because it occurs in denser medium, so whenever the ray of light strikes on the border of a medium and comes back, this border is not an opaque border. Are you understanding? It is the border between two transparent mediums. So whenever it strikes and return back, 100% intensity and energy of light will be retained as it is. Nothing will be lost. In mirror, if the reflection occurs, a little bit of energy gets absorbed because at the back the mirror is having opaque surface. So due to the material of opaqueness or opaque thing, little amount of energy is absorbed or scattered. That thing will not happen here. So prisms are used in binocular, prisms are used in periscope, because prisms always work, or prism will give you total internal reflections. That is why if those prisms are used in binocular, a small amount of energy, light energy, let it be, it is used its 100%. This is really very effective application. That's why the binocular which are made up of prism, they are highly expensive and they give you a very good quality also. Okay. So today what have we understood? We understood one stretch diagram of critical angle and total internal reflection. We understood what are those two factors which depend on critical angle, and we also understood what are those two conditions for total internal reflection. Along with that, what is the effective application of total internal reflection and why, that also we have understood clearly. In the next session, I will come up with different prisms. How does the total, in which angle, if we incident the ray of light, how does the prism behave with it, and how does total internal reflection occurs in it, and these prisms, where all they are used, all these details we will discuss in the next session. Okay children, thank you so much. Have a good day.